Hi everyone! In this video, we will solve a quadratic equation application problem. The length of one leg of a right triangle is 7 feet shorter than the other leg. If the hypotenuse is 13 feet long, find the length of each leg. To help us visualize this, let's go ahead and draw a right triangle where one leg will be shorter than the other. And we know that the legs of a right triangle are those that are attached to the right angle. So we know that one of these is going to be some length unknown, so we'll use a variable to represent that. And the other is going to be the 7 feet shorter than that. So let's take the longer of those two and we'll name it x, and the shorter one will be x minus 7. We were also told that the hypotenuse is 13, and we're working in the units of feet. Now that we have this labeled, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared, where a and b are the legs of a right triangle, and c is the hypotenuse. So we'll take a squared, which is, we'll use x squared, and then we add the other leg, in this case x minus 7 squared, and that will give us the hypotenuse, or 13 squared. And then we just need to solve for our variable x. Let's go ahead and square our x minus 7. So we have x squared plus, because this is a perfect square, we square the first, then we double the product. So x times negative 7 is negative 7x. Doubling that is 14, so negative 14x. And then squaring the last, negative 7 times negative 7 is positive 49. And then we have 13 squared, which is 169. Now let's go ahead and combine like terms. X squared plus x squared is 2x squared minus 14x. And then we can subtract 169 from both sides so that we combine the like terms there. 49 minus 169 is negative 120, and this equals 0. Now that we have a trinomial, let's go ahead and start factoring, looking first for the greatest common factor. These are all divisible by 2, so we can factor out a 2, and we're left with x squared minus 7x minus 60 equals 0. Because this is an equation, we can go ahead and divide both sides by 2, leaving us with x squared minus 7x minus 60 equals 0. Now that we have a trinomial and the coefficient in front of the first term is a 1, we can just find all of the factors of 60 to factor our trinomial into two binomials. And the factors are now that we've found all the factors, we can look at the last sign, which is negative. This tells us that the signs of the factors will be different. That means one will be positive and one will be negative. Looking at the sign of the middle term, this tells us that the larger sign will be negative. So we can go to our factors and fill in all of our larger factors with negatives, and all of the smaller factors with positives. When we combine these, we'll get negative 59 for the first, and negative 28 for the second, and so on. And we're looking for the factors that will give us the middle term of negative 7. And since positive 5 and negative 12 make negative 7, we can replace our negative 7 with positive 5x minus 12x. That gives us x squared plus 5x minus 12x minus 60 equals 0. This is 4 terms now where we can factor by grouping. So we'll group the first two and second two. And the greatest common factor of the first two is x, leaving us with x plus 5. The greatest common factor of the second two is negative 12, leaving us with x plus 5. And then we will group these two look at these two very large terms and find the greatest common factor between those. The greatest common factor between those two is the binomial x plus 5. And I ran out of room, so we're going to come right here. So we factor out x plus 5 from both terms. And we're left with x minus 12. And this is still an equation set equal to 0. Because we have two factors now equaling 0, this means that we can use the zero product property and separate our factors and set them each equal to 0. So we have x plus 5 equals 0, x minus 12 equals 0. On the left, we'll subtract 5 from both sides, so we get x equals negative 5. And on the right, adding 12 gives us x equals positive 12. If we were simply solving a quadratic equation, we would be done with our two answers. However, because this is an application problem, we need to see if it fits the application. X stands for the length of the longer of the two legs of a triangle. And because length cannot be negative, x equals negative 5 cannot be a solution. So it leaves us with x equals 12. That means that the longer side of the two legs of the triangle is 12 feet. To find the length of the shorter side, we'll substitute 12 in for x. 12 minus 7 is 5, so we end up with a length of 5 feet. So the lengths of both of these legs of the triangle are 5 feet and 12 feet. And now we're all done.